Okay, in this video we're going to show that the undrained shear strength of a normally consolidated clay is linearly proportional to the consolidation stress. So let's say we have a clay with a parallel normal consolidation line and critical state line in E, L, and P prime space. We have undrained loading, which means E is constant. So we can write out the equation for E at the end of consolidation before shearing happens. It's E naught NCL minus lambda times P naught, natural log of P naught prime. We can also write the void ratio at the end of shearing, which is E naught CSL minus lambda times ln of PF prime, where PF prime is the mean effective stress at failure. Okay, now we can equate these two expressions because for undrained loading, the void ratio is going to be a constant number. And so you end up with E naught NCL minus lambda ln P naught prime is equal to E naught CSL minus lambda ln of PF prime. Okay, we can then do a little bit of algebra to try and isolate the PF prime term, and we find that PF prime is equal to P naught prime times the exponential of E naught CSL minus E naught NCL over lambda. Let's wait for a second for the video to catch up here. All right, there we go. Now we can go to our QP prime space curve. We know that Q at failure is equal to P prime at failure times MC, which is the critical state angle in QP prime space. We also know that Q at failure is equal to 2 times the undrained shear strength because Q is the deviator stress. It could be thought of as the diameter of the Mohr circle, whereas undrained shear strength is the radius. So if we make some substitutions now, we see that Q is equal to 2 times SU, which is equal to MC times P prime F. We can make a substitution for SU in terms of P prime F, and we arrive at this equation. SU is equal to MC P naught prime over 2 times that exponential function. And then we can divide SU by P naught prime, and we get a constant, MC over 2 times the exponential. And notice that everything on the right side of the equal sign is a constant. That means that SU over P naught prime is also a constant, and it's called the normally consolidated undrained strength ratio. It's a really critical parameter to think of, and you should think of SU over P naught prime as being basically like a material constant, right? It's a single number that we can find for any kind of clay that we want, conditioned on the fact that the normal consolidation line and critical state lines are parallel. Now let's look at what happens when the soil's over-consolidated. So in this case, we consolidate down to some pressure, some maximum pass pressure, P prime max. So that's a normal consolidation phase, just like what we did before. And the expression now is E is equal to E naught NCL minus lambda times the natural log of P prime max. But of course, to over-consolidate the soil, we can't stay there. We have to unload now and let it swell, unload to some smaller P prime and some higher void ratio. So now we add in kappa, which is the slope of the unload-reload line, times the ln of P prime max over P naught prime, where P naught prime is the current vertical effective stress. All right, so we've accounted for the initial consolidation condition, and of course now that void ratio is equal to the void ratio at the end of shearing, so it's equal to E naught CSL minus lambda times ln of P prime F. Okay, now similar to what we did before, we're going to do some algebra, and I'm going to note that P prime max over P naught prime is equal to the over-consolidation ratio, OCR, right, by definition. Oftentimes we're doing vertical effective stress, here it's mean effective stress, but the idea is the same. So we do some algebra and we can define an expression for P prime at failure here. I started skipping a step and defining SU directly, but P prime at failure is going to be equal to that same exponential function with the E naught CSL minus E naught NCL divided by lambda. We'll also multiply it by Sorry, I'm struggling here with the tablet. Something's wrong with the pen. Okay, there we go. E naught NCL minus E naught CSL divided by lambda, and there's the P naught prime. And now we have an additional term, and it's OCR raised to the power of lambda minus kappa divided by lambda. So for some reason, the video recording messes up my tablet. Okay, anyway, now we can do the same thing that we did before for the normally consolidated soil by substituting in the Q at failure for P prime at failure as a function of MC, and then SU over 2 is equal to Q at failure. So we can write out that whole equation. And then we can solve for the undrained shear strength over P naught prime, right, which is the over-consolidated strength ratio now. And that's equal to MC over 2 times that same exponential function that we've been writing. But now there's an over-consolidation term in there too. So we see that over-consolidating the clay does have an effect on its undrained shear strength. All right, and so we get an OCR raised to the lambda minus kappa over lambda. And what we notice almost immediately is that the first term, the MC over 2 times the exponential function on the right side, is equal to our normally consolidated undrained strength ratio that we derived previously. So we have that the over-consolidated strength ratio is equal to the normally consolidated strength ratio times the OCR raised to some exponent, which in this case is lambda minus kappa over lambda.